Exactly to what species Hupesicus is related is unknown. Many features suggest that it is related to the ichthyosaurs, but the fact that Hupesicus's extra digits include more bones in the hand, rather than just the fingers as in the ichthyosaurs, may discredit that theory. Unlike the more derived ichthyosaurs, Cardarhynchus was probably a suction feeder, basically vacuuming up soft-bodied prey. The creature's heavy bones counteracted natural buoyancy and probably enabled it to forage in shallow coastal waters. Yet it could probably get around well on land using its flippers. Early ichthyosaurs like Omphalosaurus would have only slow movement up and down the water column. Its highly specialized dentition indicates that they were durophagous animals. Unlike other ichthyosaurs, its teeth form an irregular pavement. Eutotsosaurus has no dorsal fin and has a broad skull. It has approximately 40 presacral vertebrae which are cylindrical, suggesting that it probably swam with an eel-like motion. Eutotsosaurus is one of the most primitive grades of ichthyosaurs, a basal ichthyosaur. Chauhosaurus is one of the smallest known ichthyopterygians. It provides important information about the early evolution of the group. It shows that some typical ichthyosaurian traits were probably already part of the original Ichthyopterygian boplin. Like other ichthyosaurs, Symbospondylus probably gave birth to live young, as it had no way to lay eggs. These probably had few predators that could harm them. It probably spent much of their time hunting in deep offshore water. Like present-day sea snakes, it probably swam by wriggling its body from side to side. Its eel-like tail made up almost half the total body length and allowed it to move at fast speeds and efficiently hunt down shoals of swimming fish. Thalatorchin lived 8 million years after the Permian-Triassic extinction event, indicating a fast recovery of marine ecosystems after the mass extinction. The name Mixosaurus was chosen because it appears to have been a transitional form between the eel-shaped ichthyosaurs such as Symbospondylus and the later dolphin-shaped ichthyosaurs, such as Ichthyosaurus. It possesses more compact spongy bone within its long bones than other ichthyosaurs. Shastosaurus was highly specialized, and differed considerably from other ichthyosaurs. It was very slender in profile. It was thought to be a suction feeder and is the largest known marine reptile. Long snout and socketed teeth on Shonosaurus suggest that it may be a relatively specialized offshoot of the main ichthyosaur evolutionary line. Temnodontosaurus is known for its incredibly large eyes which, at approximately 20 centimeters in diameter, are believed to be the largest of any known animal. It likely had high visual capacity and used vision as its primary sense while hunting. It was an apex predator in the early Jurassic seas. Its habitat was in the open ocean, away from the shoreline. It lived in the pelagic zone of the water column and didn't associate with the sea floor. Excalibosaurus is a relatively rare animal known from only 2 skeletons. It is characterized by the extreme elongation of the rostrum, with the lower jaw about 3/4 of the length of the upper jaw, giving the animal a swordfish-like look. Urinosaurus followed the basic ichthyosaur body plan. One distinct feature is the upper jaw was twice the length of the lower jaw and covered with up and downwards pointing teeth. The appendage might have been used to probe through vegetation or seafloor for prey and may have been swung from side to side near the seafloor like a sawfish. Ichthyosaurus ear bones were solid, probably transferring water vibrations to the inner ear. Even so, anatomical features demonstrate that it was a visually oriented predator. They were similar to those of present-day dolphins, spent most of their lives in the open sea, where they hunted fish. Stenopterygius was a very fast swimmer, with a cruising speed similar to that of tuna. One famous fossil is that of a mother and baby that died in childbirth. This proved that ichthyosaur infants were born tail first, just like cetaceans, to prevent them from drowning before fully clearing the birth canal. Ophthalmosaurus could likely dive for around 20 minutes. It could reach depths of 600 meters more during a dive, reaching the mesopelagic zone. Scientists have found evidence of decompression sickness in the bone joints of Ophthalmosaurus skeletons, possibly caused by evasive tactics. Modern whales have been known to get the bends when they ascend rapidly to escape predators. Indirect evidence for endothermy is provided by the body shape of derived ichthyosaurs, which with its short tail and vertical tail fin seems optimized for a high cruising speed that can only be sustained by a high metabolism. All extant animals swimming this way are either fully warm-blooded or, like sharks, maintain a high temperature in their body core. However, the brain shows the limited size and elongated shape of that of modern cold-blooded reptiles. Ichthyosaurs were hard hit by the Cenomanian-Turonian anoxic event. Their last lineage became extinct for unknown reasons. Pistosaurus is known as the oldest, subaquatic flying, reptile on Earth. There are several different ways for aquatic tetrapod to counteract their positive buoyancy caused by their lungs, pachyostosis, osteosclerosis, and calcified cartilage of bone. The ultimate goal of these processes is to increase density for different parts of the body to offset the buoyancy, in order to live in an aquatic, semi-aquatic environment. Due to its bizarre dentition, Adipodentatus was formerly considered to be a filter feeder which fed on invertebrates along the sea bottom. It was suggested that the morphology made it capable of walking on land or tidal flats and sandy islands in the intertidal zone. Nothosaurs were Triassic marine sauropterygian reptiles that may have lived like seals of today, catching food in water but coming ashore on rocks and beaches. Neustichosaurus was one of the smallest. Some recovered Chychosaurus specimens feature an especially developed ulna, suggesting they may have spent some time on land or in marshes. It gave birth to live young rather than laying eggs. In many aspects, Nothosaurus' body structure resembled that of the much later plesiosaurs, but it was not as well adapted to an aquatic environment. The margins of the long jaws were equipped with numerous sharp outward-pointing teeth, indicating a diet of fish and squid. Some scientists thought that one branch of the Nothosaurs may have evolved into pliosaurs. Lariosaurus was primitive, possessing a short neck and small flippers in comparison to its relatives. This would have made it a relatively poor swimmer, and it is presumed to have spent lots of time on dry land, or hunting in shallows. Ceresiosaurus had multiple elongated phalanges, making the flippers much longer than in most other Nothosaurs, and more closely resembling those of the later plesiosaurs. It propelled itself through the water much like a penguin. Pliosaurs were carnivorous, and their long and powerful jaws carried many sharp, conical teeth, and they lived in open oceans. Unusually, Bichenopliosaurus appears to be a freshwater pliosaur. Poloneustes was one of the smallest representatives of the group. Its streamlined body allowed it to chase fast prey such as belemnites. As it had fewer and blunter teeth than its relatives, it is thought to have mainly fed on hard prey such as ammonites. Four strong paddle-like limbs suggest that Lioplorodon was a powerful swimmer. Its four-flipper mode of propulsion is characteristic of all plesiosaurs. A study involving a swimming robot has demonstrated that although this form of propulsion is not especially efficient, it provides very good acceleration. Studies of the skull have shown that it could probably scan the water with its nostrils to ascertain the source of certain smells. It was the apex predator of the late Jurassic seas that covered Europe. The largest specimen is estimated to have grown up to 6.4 meters in length. All sauropterygians had a modified pectoral girdle that supported a powerful swimming stroke. Pliosaurus and relatives had a similarly adapted pelvic girdle, allowing them to push hard against the water with all four flippers. Between its two limb girdles was a massive mesh of belly ribs that provided additional strength and support. Currently, Kronosaurus was an Australian species and is the biggest pliosaur to have ever lived. In the myth, the titan Kronos, who just so happened to be Zeus' father, tried to eat his own children, much in the same way that Kronosaurus would eat many of the smaller pliosaurs it came across. Unlike their pliosauroid cousins, plesiosauroids were probably slow swimmers. It is likely that they cruised slowly below the surface of the water, using their long flexible neck to move their head into position to snap up unwary fish or cephalopods. Plesiosaurus is distinguishable by its small head, long and slender neck, broad turtle-like body, a short tail, and two pairs of large, elongated paddles. It lends its name to the order Plesiosauria, of which it is an early, but fairly typical member. It gave live birth to live young in the water like sea snakes. The young might have lived in estuaries before moving out into the open ocean. Cryptoclydus may have used its long, intermeshing teeth to strain small prey from the water, or perhaps sift through sediment for buried animals. The fragile build of the head and teeth preclude any grappling with prey, and suggest a diet of small, soft-bodied animals. The size and shape of the nares and nasal openings were used to sample seawater for smells and chemical traces. Gastroliths have been a common find among the stomach contents of extinct marine reptiles. Their occurrence has led to two main hypotheses regarding the significance of the rocks. The first proposed usage, as described above, was to crush hard-shelled food engulfed by the animal. The second hypothesis is that gastroliths were swallowed in order to help maintain controllable buoyancy within the water column. The eyes of Elasmosaurus were located at the top of the head and allowed them to see directly upward. This stereoscopic vision would have helped it to find small prey. Hunting from below would also have been possible, with prey silhouetted in the sunlight while concealed in the dark waters below. Originally reconstructed the skeleton of Elasmosaurus with the skull at the end of the tail. The exact function of the neck of Elasmosaurids is unknown, though it may have been important for hunting. The paddles of plesiosaurs were so rigid and specialized for swimming that they could not have come on land to lay eggs like sea turtles. Plesiosaurs were even believed to have been able to maintain a constant and high body temperature, allowing for sustained swimming. With their short necks and large elongated heads, they resemble the pliosaurs, but closer phylogenetic studies indicate that they share many common features with the plesiosaurs. The shape of body of Dolichorinchops appears to have been a highly maneuverable pursuit predator, suited to chasing fish. The waters they were swimming in were teeming with other large predators.